Welcome to chemistry class. We are in the chapter periodic table. In this session 7. In this session, we are going to introduce another periodic property, that is electron affinity. In this, we need to discuss about the electron affinity and how this electron affinity is varies in periods and groups. And also we will discuss the factors which are influence the electron affinity. Now, the aim of this session is to introduce electron affinity. Now, what is the electron affinity? Electron means already you know, affinity means interest. That means in the acceptance of electron, the elements are participated readily. That means if you take any neutral gaseous isolated atom, if it is absorbs any electron, then it forms the corresponding anion along with evolution of some heat. That means the acceptance capacity of a neutral atom is called electron affinity of the corresponding element or atom. That you can say the amount of released energy when electron is added to the gaseous neutral isolated atom is called electron affinity. Amount of energy released when an electron is added to gaseous neutral isolated atom, that energy is called electron affinity. That means for an isolated gaseous atom, if you add any electron, it forms the corresponding anion and releases some energy. That energy is given by the electron affinity of the corresponding element. This indicates that in this reaction there is a evolution of energy, so it is comes under exothermic process. That means electron affinity is associated with exothermic process. That means in this reaction there is a evolution of energy. Here in the given reaction you can see this is a gaseous neutral atom. When we add one electron to this atom, it forms the corresponding gaseous anion by releasing some heat, which is indicated with minus En. That means in this reaction heat is releasing, that's why it is comes under exothermic process. Now what happened if you add another electron to the gaseous anion? That means in the previous case we are added one electron to the gaseous isolated atom. It becomes a uni-negative gaseous anion. Now to that anion if we add another electron, what happens? In generally the gaseous anion have negative charge. The electron also have negative charge. So some repulsions is occurred. In order to overcome those repulsions, the reaction or the system needs some energy. In the previous case, by adding electron, the system releases energy, but in this case, the system to overcome those repulsions, it absorbs some energy from the outside source. That means if you add any electron to the uni-negative ion, by absorbing some energy, it becomes a bi-negative anion. In this reaction you can see for the uni-negative gaseous atom, if you add one more electron, it forms the bi-negative gaseous anion by absorbing the energy. That means here the species have negative charge and electron also negative charge. So to adding the negative charge to the another negative charge, some repulsions is occurred. It absorbs some energy. That means when one electron added to uni-negative ion, there is a repulsions between negative charged ion and electron. So in order to overcome those repulsions to form bi-negative anion, system absorbs some energy. So this process is comes under endothermic process. That means second electron affinity is endothermic process. In generally for a gaseous neutral isolated atom, when you add one electron, it forms the corresponding anion by releasing some amount of energy. But to the same uni-negative ion, if you add another electron to the, because of repulsions between the charged anion and electron, it needs some energy to form the bi-negative anion. Those reactions are comes under endothermic reactions. Now, here by using the word electron affinity, you can use another word electron gain enthalpy. That means we already know by acceptance of one electron, it forms the corresponding anion and it releases some energy. That means by gaining of one electron, it releases some energy. That's why you called it as electron gain enthalpy. This would be the appropriate word instead of using electron affinity. This electron affinity is also called as electron gain enthalpy. The electron gain enthalpy is the energy change that occurs for the process of adding an electron to a gaseous isolated atom to convert those ions into negative ions or to form a monovalent anion. In generally, this is indicated with delta H, e.g. electron gain enthalpy, or you can write it as EA, electron gain enthalpy. By the reaction you can say this is the energy where to the isolated gaseous atom to react with one electron or to absorb one electron by result of forming monovalent anion. In this process, some energy is released. So the overall enthalpy of this reaction is exothermic and it is called as electron gain enthalpy for the corresponding process, that is indicated with the given reaction for the gaseous atom. By giving one electron, it forms the monovalent anion and it releases energy. The units of this electron affinity or electron gain enthalpy is kilocalories per mole or kilojoules per mole or electron volts per atom. These two are measured for mole of anions or kilojoules per mole of anions. In this, electron volts represents per atom. This has various units for the electron affinity or electron gain enthalpy. In the given picture, you can see the formation of chloride ion from the gaseous chlorine atom. By absorbing one electron, it forms the chloride ion by releasing some energy. But when you observe the formation of bi-negative anion, that is, for case it forms the O minus ion by releasing some energy. In the next case, it's already negative charge and adding another electron, it forms O minus 2. But in this case, it is called as second electron affinity. In this case, it needs some energy because there is a repulsion between the O minus ion and electron. So, it needs some energy to form a bi-negative oxygen. In this case, some energy is required. But in the case of chlorine, it forms the results of chloride ion to get the argon configuration stable form. It always releases energy. It comes under exothermic process. But for the case of oxygen, the first one is exo process and second one is endo process. In this animation, you can see how the energy is released for formation of uni-oxygen anion and how the energy is absorbed by formation of bi-negative anion of oxygen.